It is Taco Thursday, and it is time for 7.6 solving. All right, we're going to put together our half angles, our double angles, our Pythagorean identity, all sorts of awesome stuff, all into solving advanced trig functions. I'm psyched about it, okay? I just had myself some quesadilla tacos from Tacos Locos. It's their new menu item. It was delicious. All right, some tips. I'm not going to go through all of these, but I'm going to go through a little bit of a refresher here. A couple of the main ones that I want to point out. I'll use a bright color for that. So, big thing. If factoring, must set it equal to 0, right? We got to remember that, okay? Another big one, do not cancel your trig functions. You'll lose something, right? You're going to end up with multiple answers in these, most likely end up with multiple answers, because if there's a solution in, like, say, quadrant 1 for sine where it's positive, then you're also going to have that in quadrant 2 where sine is also positive, right? Feel free to pause and take a look at these, maybe write them down, screenshot them, whatever you want to do so you can have them handy as you're going through some of these problems. Otherwise, let's hop to example 1. So this first one here, we want to solve 2 cosine of theta plus 15 equals 1 for theta being between 0 and 360. All right, so if I were to say, like, let's divide by 2 first, right? I'm going to divide by 2. So now I have cosine of theta plus 15 equals 1/2. And if I were to say, so this is a cosine sum situation, right? So I could break it up like this, but when I have this here, sine of 15 isn't some nice value, so I can't do anything with that. I don't have any common factors here. I'm kind of at a dead end, right? So we're not going to want to go this route, but instead, what if I were to say, use some U-substitution, and let's go with a different color here. Let's say I let alpha equal theta plus 15, okay? Now, let's go ahead and solve this trig equation. So when does cosine equal 1/2? Well, that would be at, so alpha would be equal to 60, and alpha would also be equal to, let's see, that'd be 300, right? Awesome, so we're getting somewhere. However, that's what alpha equals. Well, what does alpha also equal? Alpha also equals theta plus 15, so we got to plug that back in. So the substitution, I think I said U-substitution earlier. I did alpha substitution in this case. Sorry, I misspoke. That helps us get this into, say, taking a problem that we don't know how to do and changing it into a problem that we do know how to do. So although when we were first introduced to this concept of U-substitution or variable substitution, it seemed like, well, what's the point of this? Like, I could kind of just figure this out. That was the case for easier problems, but as they get more complex, this allows us to change it into something that we do know how to do and go about our wonderful merry way here. I love it. 275, boom. Dunzo with that one. I said 275. Let's go 285. Subtraction is hard, right? There we go. Awesome. Fantastic. End of that period. I'm going to keep rolling because the math don't stop. The math don't stop. All right. Question 2. We can actually look at this one in a few ways. We have cosine of 2 theta is equal to 1/2. And theta is restricted between 0 to 2 pi. We're going to show this algebraically as well as graphically so we can see what the heck's going on. All right. So you can see on the guide notes key, this is going to be done in a slightly different way. I'm going to do a different way just so you can look at both aspects there. So if I have, say, cosine of 2 theta equals 1/2, I could set, again, let's say alpha equals 2 theta. So I'll have cosine of alpha is equal to 1/2. Okay. Now, let's see here. So that would be, again, at, well, we are in radians this time. So that would be what? Pi over 3. And pi, let's see here, would be 5 pi over 3. There we go. So I end up getting that. But that's, again, remember, that's what 2 theta is equal to, right? So 2 theta equals pi over 3. And 2 theta equals 5 pi over 3. So if I divide by 2, I end up getting theta equals pi over 6, and theta equals 5 pi over 6. So there's 2 solutions here. But here's the kicker. Are you ready? We're restricting theta to 2 pi, but we're dealing with 2 theta. So we need to now expand this domain for 2 theta. So we got to double everything. Now that becomes 4 pi. So we're actually talking about 2 revolutions here. So I now need to find coterminal angles for each of these, okay? So I'm going to have pi over 6, right? I'm going to have 5 pi over 6. Then coterminal of pi over 6 is if I add 2 pi, so that becomes 13 pi over 6, right? If I do add 2 pi, that'd be 12 pi over 6 added to it. And then again, adding 12 pi, that's going to be 17 pi over 6. So a couple parts here. One, I solved for that, basically that 2 theta being pi over 3 and 5 pi over 3, which gave me the pi over 6 and the 5 pi over 6. But I also had to expand that domain because we're talking about 2 theta, not just theta that we were solving for, okay? Now, I think this will help also looking at it graphically as to why do I have these 4 solutions? Well, think about what's happening for cosine of 2 theta. That is a horizontal compression, okay? So meaning for one period of that cosine function, it takes half the amount of time. So it repeats itself at pi. So over the course of 2 pi, it's going to repeat itself twice, giving you double these solutions. That was a lot to visualize in all words. Let's graph it. So I've got it all marked out here. We got 1 and 2. So cosine, we know, starts up at, right? All righty. And then, as we said, we've got, let's see here, a horizontal compression. So I'm actually going to be here, and then all the way down here, then back up in the middle, and then up here. That's 1 period. And then we're going to come back down. And there we have our wonderful cosine function. Now, we wanted to find out when does that equal 1/2? Well, how about this? Check it out. I'm going to take a ruler, put it at the 1/2 there, which is conveniently one of my tick marks since I scaled it by halves. And I'll throw a little light blue line going through there. I guess that's close enough. Boom. All right. So how many times it crossed? 1, 2, 3, 4. And those would be the values that we got. Okay. We could see it crosses 4 times. We had 4 solutions. That makes sense. And if we were to approximate those, we would know that this is about pi over 6, right? Because this is pi over 4 right here. So a little less than that. So on and so forth. Okay. So an algebraic and a graphical representation. The notes key has this done using one of your identities. So what they did, 2 cosine squared of theta minus 1 and solved. And then when you square root, you end up getting the plus or minus. You get all 4 answers that way. So cool, awesome, fantastic. Let's continue. That's enough talk about that one, shall we? All right. So number 3 here, we got cosine of 2 theta minus sine of theta equals 1. We got different wavelengths, right? We got 2 different functions going on here. But as we just said, I can change cosine of 2 theta into something else, right? I can substitute into, 1 minus 2 sine squared theta minus sine of theta. Now it's all one trig function. And we've got ourselves a quadratic, but it looks like, hey, these 1s, those are going to cancel, right? And I'm just going to go ahead and make everything then also bring it to the other side or make it all positive. So I'd have 2 sine squared theta plus sine of theta equals 0. Okay? If you need to pause the video, make sure that you understand what the heck just happened there. Cool? Because, dividing everything by -1 can be kind of helpful there. All right. Now, I've got myself a GCF, right? I don't want to have the sign on one side and cancel some out. That was one of our no-nos. So I'm going to take out a sine theta, and I'm left with 2 sine of theta plus 1 equals 0. So I can set sine of theta equal to 0, and I can set 2 sine of theta plus 1 equal to 0. And now we're sitting at this problem right here. That's one of our ones that we first learned how to solve, right? So now they're within these other problems. So when, first off, is sine going to be equal to 0? That is going to be at 0, and we're in radians pi. So there's 2 of them there. And then the other one we still have some solving to do. So I'm going to have sine, this is equals -1 divided by 2, and I get sine of theta equals -1/2. I like it. So when does sine equal -1/2? Well, it's going to be negative in the third and fourth quadrant. And that's going to be, 7 pi over 6 and 11 pi over 6. I think that's good. It's good. All right. I like it. Good stuff. So there's all 4 solutions there, right? Whether you use unit circle or special right triangles, I imagine the special right triangles and knew that with the 1 being the opposite side, that I'm dealing with a 30-degree reference or a pi over 6 reference, and that's how I got mine. Unit circle works too. All right, there we go. 4 solutions. Love it. Fantastic. Moving on. All right. So this next one here, we have sine of theta equals sine of 2 theta. That's a little weird to deal with, but hold up. I got an idea, okay? This sine of 2 theta, isn't that 2 sine of theta? Whoa. Cosine of theta. And although I've now made this into 2 different functions, take a look. If I bring this over to the other side, takes a little future telling here to see what's going on. You'll get better at that as things go. I can take out a GCF of sine from both of these, can't I? So if I can take out a sine from both, leaving me with 1 minus 2 cosine of theta, I'm basically dealing with the same type of situation that we had up here in this problem when I got to that step, right? It's basically the same exact situation, except for I'm dealing with cosine now. So I can set each one of these equal to 0. I already know that's 0 and pi. And then 1 minus 2 cosine of theta equals 0. So I'm going to get cosine of theta equals positive 1/2, because it's going to be -1 divided by -2. Where does cosine equal positive 1/2? Well, that would be in my first quadrant at pi over 3. And in my fourth quadrant at 5 pi over 3. Beautiful. Fantastic and wonderful. All right, and if you need maybe a little visual, maybe I should give you one of those. That's pi over 3. That would be our 1 and 2, which is my root 3, right? It's a 30, 60, 90 triangle. And the other one was down here. I like it. Good stuff. In case you forgot how to draw your triangles. Cool. Awesome. Fantastic. Wonderful. Love it. Next one here. And again, I'm trying to keep things a little bit or moving quickly here, just to keep our video length down. Okay, hold up. My goodness. Tangent now? We're doing tangent now? Are you crazy? I'm not crazy. I'm excited. All right. So tangent of 2 theta. Let's address that first. How about? Let's see here. 2 tangent of theta over 1 minus tangent squared theta, right? And that's going to equal 3 tangent theta. So now at least I'm just dealing with of theta, and not 2 theta, right? Perhaps this will help. I got a fraction though. I want to deal with that. I'm going to multiply by 1 minus tangent squared theta on everything. So 1 minus tangent squared theta, 1 minus tangent squared theta. When I mean everything, I mean both sides. That cancels it. And now I'm left with 2 tangent of theta equals, and I'm going to distribute right now because I'm crazy like that. 3 tangent theta minus, oh boy, 3 tangent cube theta. Had to pause. People came in. All right. We're dealing with, oh my goodness, I'm going to have faith in the process, okay? Trust the process here, children. So I'm going to bring everything to one side, right? I'm going to set it equal to 0 because it looks like we're going to be dealing with some form of factoring, right? Probably GCF here. So if I do that, I'm going to have 3 tangent cubed theta minus tangent of theta equals 0. Okay. I like that. You know why I like that? I like it so much because I can factor out a tangent of theta. And now I'm left with 3 tangent squared theta minus 1 equals 0. And although that might be like, ugh, it's all good, okay? It's Gucci, as they say. So I'm going to switch colors here so it doesn't get lost in the lines of work. So now I'm going to have tangent of theta equal to 0. And I'm going to have 3 tangent squared minus 1 equals 0. And we've solved, almost forgot my theta, we've solved those before. I'm going to deal with tangent equaling 0 right off the bat here, okay? That's y over x, right, or sine over cosine. So when is sine equal to 0? That would be at 0 and at pi. So, and we are in radians. 0, comma pi. I like it. Good stuff. If you're ever like, hey, man, when does that happen? Like you forget, like because it's been a little while since unit circle. I think tangent is slope, okay? So along that x-axis, that's a horizontal line. That's a 0 slope. So to go from the origin to that guy out at 0, I went up nothing, 0 slope, right? And to the left, 0 slope. At least that's, maybe I'm crazy. I don't know. I like to relate it that way. Next one. I'll keep them separate. So I've got to add 1, divide by 3. So I'm going to have tangent squared theta equals 1 over 3. Now, fit about a square root on both sides. So I'll have tangent of theta equals positive or negative. And to rationalize this, because it's going to be 1 over root 3, that's going to be root 3 over 3. Yeesh. Or just 1 over root. Either way, honestly, however you want to look at it is fine. You know what? I kind of, as a triangle person, I kind of like this. Because this is opposite, adjacent, and that makes me think of my special right triangles. Let's go with the positive one first, and then we'll deal with the rest. Opposite being 1, adjacent, it's 2. This is a pi over 6 situation for my reference, right? A 30-degree reference. So, boom, there's one of my solutions. Pi over 6. And then, what do we got next? Let's see here. The other one's going to be 5 pi over 6. I'm just going around the world here. 7 pi over 6 and 11 pi over 6. I got all positive and negative. We're good to go. That's 4 more solutions for theta. Whoop. And 0 and pi, all 6. When you're typing these things into MyMathLab, you need to have all 6 or it is incorrect. So double and triple check that you plugged them or typed them in correctly, because one wrong one, whole thing's wrong, okay? Don't mess that up. You'll be very upset with yourself. All right. So again, I decided to go not rationalize, use my special right triangles. I think that's really helpful with tangent rather than dealing with like reciprocals and all sorts of stuff with the unit circle. But to each his own, right? Whew. Number 6, we saw something like this at the start. Problem number 2 with the cosine. And let's see here. If I went to use an identity, that would be 2 sine theta cosine theta equals 1. I'm going nowhere, okay? Right? Going nowhere. Whoever that dude is. Was that Randy Savage? Macho Man Randy Savage? Yeah, I think so. All right, so I got to rethink. Can't do that. But what if I say, hey, man, 2 theta equals alpha? You don't necessarily have to use alpha or U-sub. You can go about it however you'd like. But let's solve this. Sine of alpha equals 1/2. So that would mean, let's see here. That's going to be and we're doing radians, right? We're doing radians. So it's going to be a pi over 6. That was a really extravagant alpha. Pi over 6. And we got ourselves, where else is it positive? That'd be 5 pi over 6. Well, remember, this is what 2 theta equals. So theta is going to equal pi over 12 and 5 pi over 12, right? Okay. I like it. But as we said before, we're missing some solutions here. So if I'm solving for theta, that's between 0 and 2 pi, right? But 2 theta is between 0 and 4 pi. And this is actually something I feel like I didn't cover quite perfectly in the second example, so I want to hit that now very well. So 2 theta is going to have to be between 0 and 4 pi. So let's add some solutions to this one. So if I go around again, right, another revolution, that's going to be, let's see here, 12 pi over 6, so 17 pi over 6. And then again, sorry, actually I should do pi first, my bad. So that'd be 13 pi over 6, and then 17 pi over 6 when I add 12 to 5. So that's what 2 theta is. And then to get the rest of theta, I would divide by 2 on those as well to get 13 pi over 12 and 17 pi over 12. Wonderful. So that's what theta equals. The one above that is what 2 theta equals, which is between 0 and 4 pi, right? This is within 4 pi. 4 pi would be what, 24 pi over 6? So this is within that, okay? And another revolution would be, that'd be 29 pi over 6, which would be out of the 24 pi over 6 we just said. So we have all of them in that 2 theta arena, if you will, within the 2 theta bounds of 0 to 4 pi. And now we've got that into theta. So multiple steps on these. And I feel like I didn't address the 2 theta aspect in the first example as well as I did here. So hopefully that provides some clarification. Lovely. Let's keep moving. Oh my goodness gracious. We've got cosine of 4 theta equals -1 minus 3 sine of 2 theta. We got 4 thetas, we got 2 thetas, we got 2 different trig functions. What the heck are we going to do? All right. Substitution, variable substitution to the rescue. I'm going to set alpha equal to 2 theta. Let's rewrite that. I'd have cosine of 2 alpha equals -1 minus 3 sine of alpha. What can I rewrite cosine of 2 alpha as? 1 minus 2 sine squared alpha. So once again, what did we do with variable substitution, often U-Substitution, but in this case, alpha substitution? We transformed a problem we did not know how to do into a problem we do hopefully know how to do, right? Okay, so I've got myself a quadratic situation going on. Let's bring everything to one side. I'm going to go to the right side because I want my leading guy to be positive. So I'd have 0 equals 2 sine squared alpha, and then I'd have minus 3 sine alpha, and then minus 2. And if it makes you feel a little more warm and fuzzy inside, feel free to just pop that 0 over here. I feel like you might feel more warm and fuzzy inside if I had the 0 on the right. So that's cool with me. Or you can bring everything over to the left and then divide by -1. I think this works just fine. Now, we have to factor with a lead coefficient. I bet you're pumped about that. So let's do it, okay? Now, either you can factor like this here, or perhaps, guess what? Let's go with, let's use U-Substitution. U equals sine of alpha. Let's substitute again, shall we? And I'm going to do different colors so we can see the different parts. And there we have it. U is equal to sine alpha. So now I have 2u squared minus 3u minus 2 equals 0. And I'm going to go ahead and factor. Now, either you can do rainbow method, guess and check, whatever you want to do. I think a lot of you use rainbow methods, so I'll go with that. Let's see here. We got 2 times -2, that's -4. So we're going to have -4 and +1 as my numbers. So I will have 2u squared minus 4u plus u minus 1, or sorry, minus 2 equals 0. Group them. Factor out my GCF. 2u times u minus 2, and then plus 1 times u minus 2. So I've got 2u plus 1, and then, and then we have u minus 2. All right. But we got to substitute. So I'm going to bring it back up here. Now we're going to substitute that sine alpha back in. I'm going to change colors again so that we're going from like part to part in these. So I would have 2 sine of alpha, right, plus 1. And then I'd have, so your sine of alpha minus 2 all equals 0. Lovely. So now we can actually solve for alpha, but don't forget, we substituted for alpha. So I'm going to have 2 sine of alpha plus 1 equals 0, and sine of alpha minus 2 equals 0. And I'm running out of a little room. I'll scooch it a little bit. So I get sine of alpha equals -1/2. Sine of alpha equals 2. Thankfully, can sine ever equal 2? No, it's opposite over hypotenuse. Hypotenuse has to be the largest side, undefined. All righty. So we've nixed that one, which is just oh so fortunate. Now I need to figure out, hey, when is alpha, or when is sine to be equal to -1/2? That's going to be in my third and my fourth quadrant, right? Because that's when my opposite side is negative. Or if you remember ASTC. All right. So that would be what? 7 pi over 6, and we're going to have 11 pi. Not pi, 11 pi over 6. Okay. So this, again, this is what alpha equals, right? What does 2 theta then is equal to 7 pi over 6 and 11 pi over 6. I'm actually going to give myself a little more room here and rewrite it. All right, so if 2 theta is equal to 7 pi over 6 and 11 pi over 6, we got to remember that theta was restricted to 0 to 2 pi, right? But 2 theta is restricted from 0 to 4 pi. So I've got to coterminal these bad boys. I got to find the coterminal. So if I add 12 pi over 6 to 7 pi over 6, I'm going to get 19 pi over 6. And then if I add 12 again, I'm going to get 23 pi over 6, just within my 4 pi restriction there, right? Because 24 over 6 is going to be 4. 23 just within. All right. Beautiful. So that's 2 theta. So then to get theta, I've got 7 pi over 12, 11 pi over 12, 19 pi over 12, and 23 pi over 12. That was quite the problem there. A delicious math problem, if you will. Almost as delicious as the quesadilla tacos that I had today. And to tell you what the birria is the beef, the braised beef that they had. And then the queso's the cheese, right? I learned that from Mr. Philpott. I usually don't like to give him too much credit, but I will on the quesadilla tacos with the I can't remember what it is. But it's like this, you dip it in, right? It's the stuff that it was cooked in. Delicious. I highly recommend. All right. That was a good one. That was intense, right? So we did a few things. Let's recap that before we do our last problem. We did alpha substitution for 2 theta, solved. Then I did U-substitution to make it a little easier for me to factor with a lead coefficient. Then I substituted back in. Then I had to address the 2 theta that I solved for, which would be an expanded domain of 0 for 2 theta all the way up to 4 pi. And then solve just for theta because I had only solved for 2 theta, but I really wanted theta. So I divide everything by 2, and then boom, that puts it all nicely within my domain restriction of 0 to 2 pi for theta. I'm out of breath. All right, let's tackle this last one. We're going to cut it short from the identities that we were planning to do next, but this video is getting a little lengthy, so we're going to cut it off here. All right, this one. Oh boy, yay, once again. We got 2 different trig functions. I'd like to challenge you to try this one yourself. I'm going to give you the first tip here, unless you want to just pause it and start going. But I'm going to say alpha is going to equal 2 theta once again. Feel free to pause it, try to work through this whole thing, and then I'm going to go through it. I'll try to go quick to save on video time. Pause it, do it. I'm going to get a drink until you pause. All right, time to go through it. Hopefully you paused it. So first thing I'm going to do is substitute that in. So I'm going to have cosine of 2 alpha plus sine squared alpha equals 0. Lovely. Fantastic and wonderful. Now, I know that cosine of 2 alpha could be changed into 1 minus 2 sine squared alpha plus sine squared alpha. And how conveniently wonderful and fantastic is that? So I'm going to have 1 minus sine squared alpha equals 0. Now, I got a couple options here. I could either change that into, I believe, cosine squared theta, or I'll deal with it right now because it's not a big deal. I would, let's see here, subtract 1, divide by a negative, and get sine squared alpha is equal to positive 1. All right. Now I'm going to square root on both sides, and I get sine of alpha is equal to plus or minus 1. Cool. So when Does sine equal positive 1? Well, that's going to be at, so alpha is going to equal pi over 2. Where else? Nowhere else does it equal positive 1, but it does equal negative 1 at 3 pi over 2. Now, keep in mind, the alpha was in fact 2 theta. So 2 theta is equal to pi over 2 and 3 pi over 2. Some people substitute the 2 theta back into sine and then just set 2 theta equal. To each his own, okay? Many different ways here. Now, I got to divide by 2 on everything. Actually, first though, I have my expanded domain, don't I? From 0 to 4 pi now because it says that theta is between 0 and 2 pi. So 2 theta is going to go up to 4 pi. Right? I'm multiplying everything by 2 right through. Nice. So we got to get a couple more coterminal angles to account for that extra rotation around the unit circle. So if I add 2 pi, or in this case 4 pi over 2, I get 5 pi over 2, and I'd get 7 pi over 2. Now that I have all 4 solutions for 2 theta, which I'd like doing that, getting all 4 for that. I might not have done that on the first one. I can't remember now. It's been 30 minutes from then. Now I'll divide everything by 2 to get to just theta. So I get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. That's it. That's the end of the period. I had to finish the video then anyways. That was perfect timing. I hope you guys enjoyed. That one's intense, but it all kind of leads up to that with those different identities, and it's cool to use them. I find it cool. Maybe you don't, whatever. But you guys have a great day. American Freedom, Rock and Roll Costco, Riverdog Jenny on the gram. Thanks for sticking around.